Hello everyone, I am Dr. L. Padmasree, Professor in Department of ECE at VNR VJEC. And today we will record the material for electronic circuit analysis subject. So one of the unit in electronic circuit analysis is feedback amplifiers. In this video, the topics covered are concept of feedback, block diagram of feedback amplifier, and the types of feedback and its advantages. First we will learn about concept of feedback. Feedback is defined as the process in which a part of the output signal is either voltage or current returned back to the input. Feedback plays an important role in electronic circuits, and basic parameters such as input impedance, output impedance, current gain or voltage gain, and bandwidth may be altered. Feedback is also used to control gain and improve performance of the circuit. The amplifier that operates on the principle of feedback is known as feedback amplifier. So first we have to know about what is the function of the amplifier. Amplifier is a circuit which amplifies input signals without any distortion. Vi is input voltage of the amplifier, V0 is output voltage of the amplifier, AV is gain of the amplifier without feedback. Therefore, voltage gain of the amplifier is defined as ratio of output voltage to input voltage. AV is equals to V0 by Vi. So next we will learn about what is the block diagram of feedback amplifier. Main blocks are signal source, mixer network, basic amplifier, sampling network, feedback network. So first we have to know about what are the terms used in this analysis. Vs is signal source, Vi is input voltage of the basic amplifier, V0 is output voltage, gain of the amplifier without feedback is AV, AV is equals to V0 by Vi. Gain of the feedback amplifier is defined as ratio of output voltage of the feedback amplifier to that of input of the feedback amplifier. What is the output of feedback amplifier? V0. Input of feedback amplifier is Vs. Therefore, gain of the feedback amplifier AVF is equals to ratio of V0 to Vs. Then Vf is output of the feedback network. V0 is also equals to input of the feedback network. So therefore, gain of the feedback network or feedback factor beta is equals to Vf by V0. So now we are clear about that. AV is gain of the amplifier without feedback, that is V0 by Vi. Gain of the amplifier with feedback AVF is equals to V0 by Vs, and gain of the feedback network or feedback factor beta is equals to Vf by V0. So next we will see about what are the details about each block of the feedback amplifier. Signal source can be either voltage source or current source. Feedback network is a two-port passive network which contains resistors, inductors or capacitors. So what is the function of the feedback network? To return the part of the output voltage or current to input of the basic amplifier. Sampling network samples the output signal which is either voltage or current and fed back to the input of the feedback network. Next block is mixer network. Mixer network combines signal source and output of the feedback network and fed to the input of the basic amplifier. So basic amplifier is a circuit which amplifies input signals without any distortion and provides large output signals. So next we will learn about what are the types of the feedback. There are two types of feedback. One is positive feedback and another one is negative feedback. So first we have to learn about what is meant by positive feedback. If the positive feedback voltage Vf is in phase with the signal source, Vs, then net effect of the feedback will increase the input signal which is given to basic amplifier. Then Vi is equals to, Vi is input voltage of the basic amplifier, that is Vi is equals to Vs plus Vf. Hence input voltage applied to the basic amplifier is increased, thereby output voltage of the amplifier is also increases. This type of feedback is known as positive feedback. Now we will see the derivation for gain of the amplifier with positive feedback. So gain of the amplifier with positive feedback, AVF is ratio of output of the feedback amplifier to that of input of the feedback amplifier. So V0 is output of the feedback amplifier, Vs is input of the feedback amplifier. Therefore, AVF is equals to V0 by Vs. Then substitute Vs is equals to Vi minus Vf in the above equation. Then AVF is equals to V0 by Vi minus Vf. Then divide with output voltage V0. By dividing with V0, the above equation becomes AVF is equals to 1 by Vi by V0 minus Vf by V0. What is Vi by V0? 1 by AV, because gain of the amplifier without feedback AV is equals to V0 by Vi. Then substitute Vi by V0 is equals to 1 by AV. So what is feedback factor? Feedback factor is ratio of output of the feedback network to that of input of the feedback network. So therefore beta is equals to Vf by V0. Substitute AV and beta in the expression of AVF. Then AVF is equals to 1 by AV minus beta. By simplifying this expression, then AVF becomes to AV by 1 minus beta AV. So now we have to learn about what are the terms. AVF is voltage gain with positive feedback, and AV is voltage gain without feedback, beta is feedback factor. So we got the expression for AVF is equals to AV by 1 minus beta AV. Therefore, voltage gain with positive feedback is greater than that of without feedback. So therefore, AVF is always greater than AV. We will learn about what are the advantages and disadvantages of positive feedback. So the product of open loop gain, AV, and feedback factor is also known as closed loop gain, that is called beta AV. Closed loop gain depends on amplifier gain and feedback factor. If AV beta is equals to 1, then AVF is infinite. The amplifier gives an output signal without applying any input signals. Hence, the amplifier acts as oscillator if the positive feedback is present. What are the advantages of the positive feedback amplifier? Because AVF is greater than AV means gain of the positive feedback amplifier increases. Next, we will see about what are the disadvantages of positive feedback amplifiers. Stability decreases and distortion also increases. Due to these disadvantages, the positive feedback is not recommended for amplifiers. If the positive feedback is sufficiently large, it leads to oscillations and it can be used in oscillator circuits. So next type of feedback is negative feedback. In negative feedback, if the feedback voltage is out of phase with the signal source, then Vi is equals to Vs minus Vf. Hence, the input voltage applied to the basic amplifier is decreases and the corresponding output also decreases. So next we will see about derivation for gain of the amplifier with negative feedback. So what is the definition for gain of the amplifier with negative feedback? AVF is ratio of output voltage to input of feedback amplifier. So what is the output of feedback amplifier? V naught. What is the input of feedback amplifier? Vs. Therefore, AVF is V naught by Vs. But in negative feedback, Vi is equals to Vs minus Vf. What is Vs from this equation? Substitute Vs is equals to Vi plus Vf. Then AVF is equals to V naught by Vi plus Vf. So divide AVF with V naught. Then AVF is equals to 1 by Vi by V naught plus Vf by V naught. So what is AV? AV is gain of the amplifier without feedback. AV is equals to V naught by Vi. And feedback factor beta is equals to Vf by V naught. Then AVF becomes to 1 by AV plus beta. By simplifying this expression, AVF is equals to AV by 1 plus beta AV. What is AVF? Gain of the amplifier with negative feedback is equals to ratio of voltage gain without feedback to that of 1 plus beta AV. So then from this expression, you can clearly understand that AVF is less than AV. What is the meaning for this expression? Voltage gain with negative feedback is less than that of without feedback. So that means in negative feedback, gain decreases. In positive feedback, gain increases. So that's what we have to understand from this analysis. Next, we will see about what are the disadvantages of negative feedback. Disadvantage is gain decreases, but it has so many advantages. Advantages of negative feedback are stability increases, distortion decreases, noise decreases, but bandwidth increases. Input and output resistance can be modified according to the type of the feedback. Due to these advantages, negative feedback is frequently employed in amplifiers. So next we will see about what is the comparison between positive feedback and negative feedback. In positive feedback, feedback signal is in phase with the signal source. In negative feedback, feedback signal is out of phase with the signal source. Then positive feedback is also known as regenerative feedback. Negative feedback is known as degenerative feedback. So gain of the in positive feedback, gain of the amplifier is high. In negative feedback, gain of the amplifier is less. In positive feedback, stability is less. In negative feedback, stability is more. The phase shift of positive feedback is 0 degrees or 360 degrees because feedback signal is in phase with the signal source. The phase shift of negative feedback is 180 degrees because feedback signal is out of phase with the signal source. The positive feedback can be used in oscillators. The negative feedback can be used in amplifiers. So in next video, we will cover effect of feedback on amplifier characteristics. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.